This is the easiest quadratic factoring technique I've ever seen. If you just basically do the steps, it works. You don't even really have to know what you're doing or why. There's definitely a place for that. Many times it is preferred, but if you just want a way to get the job done and get your math credit, this is probably the best way to go about it. So here's what you're going to do. Let's take this first one, and we already know we're going to do two parentheses. This is quadratic factoring. This is for quadratics that have a leading coefficient of 1. As you probably know, the number right here, the implied number is 1. All of these have a 1 as the leading coefficient, except for this one down here. Our x squared term has a negative. We're going to deal with that. But let's do this one first. So you're going to put your variable in the front of each parenthesis. You're going to take this sign and you're going to bring it straight down. Over here, you are not going to bring this sign straight down. You are going to look at both of these and think about multiplication rules. A negative times a positive is a negative. Now, we are looking for two numbers that multiply to 14. Really, it's 1 times 14. That's how this works. But since the leading coefficient is 1, then you can just think of it as 14. So we want two numbers that multiply to 14, but add to 9. Okay, not this sign, and this number. So let's think about all of the possible candidates. We need to take 14 and factor out all the possible pairs. So just always start with 1 and the number. And then think, does 2 work? Yeah, it does. 2 times 7. And that's going to be it for this. Sometimes you have a really long list. Sometimes it's really short like this. Well, what are the two numbers here that multiply to 14, add to 9? Well, it's going to be these. Write the bigger one first, smaller one in the second parenthesis. Now here, obviously, it wouldn't have made any difference, but just always write the bigger one first and you'll always be correct. Now, if you FOIL this back out, you'll see that this is equal to this. Let's do another one. I'm going to bring this sign straight down. I'm going to think about multiplication rules. A negative times a positive is a negative. And I need two numbers that multiply to 36 and add to 15. So let's make all the pairs that we can. 1 times 36, 2 times 18. If you're not real good at the multiplication tables, then just start with 1, plug it in. Well, you don't have to do 1, but 2, plug it in, plug in 3, plug in 4. Just go right on up the list until you've got all that you need. Or you may see that 1 works before you complete the list. So don't waste your time. Okay. 3 times 12, 4 times 9, 6 times 6. Obviously, there's not going to be any more because when these meet in the middle, you notice these are increasing, these are decreasing. Well, when they meet in the middle, that's all you're going to get. So which of these numbers add up to 15? Well, it's going to be these. So we didn't even have to complete the list, but I did it just to, complete the illustration. Write the bigger number first, smaller number second, and if you FOIL this, you'll see this is equal to what we started with. Next one. Okay, bring this sign straight down. Positive times a positive is a positive. We need two numbers that add to 21 and multiply to 54. So what are all the possibilities? 2 works. 3 works. 4 doesn't work. 5 doesn't work. 6 works. Okay, the only two left would be 7 and 8, and neither one of those works. But do we already have something that adds up to 21? Well, here we go. Again, I'm completing the list unnecessarily. Write the bigger one first. Again, it wouldn't have made any difference here, but just always write the bigger one first. And we have factored this trinomial. Bring the plus straight down. Plus times a minus is a minus. So this is not minus because this is minus. This is minus because a positive times a negative is a negative. We're looking for two numbers that multiply to 18 and subtract to 3. So let's make our possible factor pair list. Always do 1 in the number, and sometimes this is going to be it. Sometimes you don't even have to keep going because you'll see this one does it. Okay, 2 works, 3 works, and 4 doesn't work, 5 doesn't work. So this is all we're going to get. Which of these subtract to 3? Well, these are the ones we want. Write the bigger one first, smaller one second, and if you FOIL this, you'll see these are equal. Next. Negative, and a negative times a negative is a positive. And we're looking for two numbers that multiply to 12 and subtract to 4. So does 12 divide by 2? Yes. Does it divide by 3? Yes. And that's as far as we're going to get. So does some pair in here subtract to 4? Well, it would be this. Now, if you do every possible factor pair and none of them do what is specified here, that means you have a prime trinomial. That means it does not factor. And sadly, in real life, most trinomials don't factor. But if you're given a math sheet and told to factor these, then, you know, they're either going to work, or the sheet may say factor these or state if it's prime. So if you do this and it doesn't work, then just state that it's prime. In this case, though, we do have a pair that multiplies to 12 and subtracts to 4. We write the bigger one first, and we're done. If you FOIL this, you will get x squared minus 4x minus 12. Next. Okay, now we need numbers that multiply to 75 and subtract to 22. Okay, does 2 work? No. Does 3 work? Yes. Again, just get your calculator out, plug in a 2, a 3, a 4, a 5, and a 6. Go right on up the line. Does 5 work? Yes. 6 doesn't work, 7 doesn't work, 8 doesn't work. If you go right on up, you'll see this is going to be all there is. So I'll stop here. But do we have a pair that subtracts to 22? And yes, we do. Okay. I should have put an equal sign over here. What if you have a negative on your leading coefficient? Well, we don't want that. So you need to factor that out. So just factor out a negative 1. If you want to put a 1 there, do it. Okay? A negative is the same as a negative 1. But I'm not going to put it. On second thought, I will. Okay. Well, what's going to be in here? Well, it's just going to flip all the signs. Okay. You'll see if you distribute that -1 back in, then you will get this back. If you just follow multiplication rules, all your signs will flip and you'll get that back. Okay, now, so this is what we're going to factor. Where the negative, it's still going to be sitting there when we're done. We don't care about that anymore. It's just sitting there. Right now, all we care about is the inside part. Bring the negative down. Multiplication rules for this, that's going to be a negative. We're looking for two numbers that multiply to 36 and subtract to 13. So does 2 work? Yes, it does. Does 2 work? Yes. Does 4 work? Yes. 5 doesn't work. 6 works. And which of these do what we want? Add up to 13. Actually, that part right there was a mistake. We don't want that. Let me get a different color. We want them to add to 13. So forget about that right there. So our two numbers are 4 and 9. And we're done. And if you FOIL this and then multiply that negative by everything in there, you will get this back. Okay, just remember, don't make the mistake I just did. Don't look at this to get your criteria. Look at the one where you have factored out the negative, and then whatever that sign is, that's, you mix that and this number. So here, this has to add to 13, not subtract to 13. If you try to subtract to 13, none of this would have worked.